Hello everyone, it's Benny, and in this video we're going to talk about profiling our game engine. Now, profiling just means gathering various statistics about how different parts of the engine are performing. And the idea is, once you know those statistics, you'll be able to identify what parts of your engine aren't performing as well as you'd like, and you can focus your optimization efforts over there. So that's the idea of profiling. And there's a lot of ways you can do this. In fact, there are a lot of third-party tools you can use which will help you run and profile your app with a whole bunch of various data. But in this video, I'm going to go for a rather basic profiler. One that's integrated into the engine and can give just basic statistics to help us find, well, various areas that aren't performing like we'd like. And yeah, so if you want to follow along, the source code for the engine, both before and after the profiling is integrated, will be in the description, and the build instructions are in the README. So yeah, let's dive in, and let's get started. Now, the most basic form of profiling you can do is just measuring how long something takes. And in our core engine, that's exactly what we're doing. We're just measuring how long it takes for the engine to go from having fully finished processing and drawing one frame to having fully finished processing and drawing the next frame. But that's not ideal. Why? Let's say something suddenly takes 10 seconds to do for one frame. Our tool will tell us it takes 10 seconds, but that's not that helpful. We don't know if that's 10 seconds because the renderer just totally failed and took forever for some reason, or it's 10 seconds because we had to load this really big mesh or something. You know, we don't know what caused that 10 seconds. We just know it took 10 seconds. So ideally, we'd make this a little bit more fine-grained. Just, at the very least, profile individual subsystems like the rendering engine and such, rather than just the global, this is how long one frame takes. So, I went ahead and created profiling.h and profiling.cpp off-screen, and these will just be the files for our new profiling code. So, let's get started. I'm going to create a class I'm going to call profile timer, and this class is going to be, basically, it's going to be embodiment of the basic profile timing paradigm, as the name suggests. And the way this is going to work, we're going to have some int num invocations. So this is however many times what we're measuring has been called. And we're going to have a double and I'm going to align these because it's going to bother me, total time. And that'll be the total amount of time spent doing whatever was invocated. So that is the way this works. And what I'm going to do is I'm just going to have a couple methods to manipulate these. So I'm going to have some void start invocation and void stop invocation. So that's how we're going to measure things. We're going to start some invocation and we're going to stop some invocation. And really, that's all we need for this. So I'm going to copy those functions, and I'm going to move them into the implementation file, which I've already included profiling.h in, by the way. And now we're going to implement these. And they're really not that hard to implement, but, you know, so don't worry. That's my point with that. So starting the invocation, what I'm going to do is I'm going to say we're going to well, actually I'll do that. There's some things you can do in either start or stop, and one of those is incrementing the number of invocations. I'm going to increment the number of invocations in stop. And I'm also going to update total time in stop. And how I'm going to do that, you'll see in a moment. What I'm going to do, the way I'm going to do this, is I'm going to have some, well, I'm going to have some double start time. And so yeah, I did forget about that, sorry. And when I start my invocation, I'm going to include timing.h so I can use time get time. So our start time is now that. And when I stop the invocation, I'm going to increment the number of invocations, and I'm going to say total time plus equals, time, well, yeah, time get time minus start time. And just to make sure I don't accidentally call this again without calling start invocation, what I'm going to do is here is I'm going to say start time equals 0. In fact, I'm going to import, I'm going to create sort of a dummy constructor, which is just going to, assign to everything. So num invocations 0, and total time, and etc., also 0. So total time is 0, and start time is 0. That's going to be 0.0 because that's a double. There. And what I'm going to do here is I'm going to use cassert. So I'm going to include cassert. Just as a basic way of ensuring, I'm going to assert start time is not equal to 0. Well, actually, just to give it a little bit more description, I'm going to do this. If start time is equal to 0, well, then I'm going to include IOStream, and just print the user an error message. I'm going to output, hey, you forgot. No. I'm going to display error. Stop invocation called without matching start invocation. There. And I'll just use the assert thing to make sure it doesn't, just to stop everything, just so we don't keep running with faulty data. And there, that's our profile timer. And I actually forgot a function. That's the void display and reset function. This is going to do exactly what it says. It's going to display our current profiling statistics, and it's going to reset everything. And it's also going to take in a const std string reference for some message, so we can have some message to display with. And that'll mean we'll need to include string. So, with that, let's go into profiling.cpp, and let's implement this. And so, profile timer, : display and reset, yada yada. So, I'm going to need to, of course, std cout the message, then I'm going to do : space, and then I'm going to do a calculation very similar to what I have in core engine.cpp. So I'm going to copy and paste that for the time being. And then std indel. Wait, almost forgot something. And then I need double arrow. And this is going to be space milliseconds, because we're displaying in milliseconds. And also, because we're displaying in milliseconds, we're going to need to take our total time and multiply it by 1000 at the top here. So 1000 times total time, because that converts seconds to milliseconds. And then we're going to divide that by double num invocations. So there. And then finally, at the end here, we're going to say total time equals 0.0. So there. And num invocation, again, goes back to 0. So there. And that does exactly what it says. It displays everything, and it resets. So let's build to make sure I don't have any errors. And I don't, so great. Now, let's go ahead and use our basic profiling tool to profile our rendering engine, at least a little bit. So, I'm going to go into my headers and go to renderingengine.h. Why? Because we're now going to be, one, including profiling.h, and we're also going to be adding a new variable here, or new member variable. That's going to be profile timer. I'm going to call m_render profile timer, because this is going to be the profile timer for the render function. And you might be wondering, well, why does this need to be a member variable? Because I'm going to have a function, a public guess it's method, and it's going to be void display profile info. And actually, this is going to be inline, and the reason it's going to be inline is because this is just going to be a wrapper for mRender profile timer dot, well, I guess it's not finding it for some reason, but it's a display and reset function, or method. And it's going to display that with the message of render time. And yeah, I'm going to do colon space here instead of this, so I'm actually going to get rid of that, because otherwise that's going to bother me. And there. So with that, all I have to do is use the render profile timer in Rendering Engine. So yeah, in my render function. So at the top, the easy way to do this is mRender profile timer dot start invocation, and then at the bottom, mRender profile timer dot stop invocation. Whoop. Stop invocation. There. And technically this will work. One thing you do have to be careful of with specifically profiling a render function. Some systems, such as the one I'm using, will actually synchronize when you write to the window. And, well, you don't want to take in... Yeah, you probably don't want to take into account the whole synchronization time when you're doing that. So, what I'm going to do is I'm going to cut that. I'm going to do that above the apply filter function. So, yeah, this won't take into account the time it takes to apply the FXAA filter, but this way we aren't erroneously taking into account all the time it takes to synchronize to the display. And yeah, so with that, all I have to do is in CoreEngine.cpp, I'm going to say mRenderingEngine arrow display profile info. And actually, I'm also going to uncomment the line with that I used to be using, just so I can say total time, colon, that. That way I know both the amount of time it takes to render and the amount of time it takes in total. So with that, we should have some basic profiling for our rendering engine. So if I build and run, well, look at that. Now we know how long it takes, well, just in the render function. And as you see, it's taking about 2 milliseconds to render. So, great. And we know that in total it's taking 16 milliseconds, largely because of that synchronization thing. But yeah, so, now that we have something that works in the basic sense, I'm going to make 2 changes to make our profile timer a little bit more useful as a general profile timing tool. First off, I'm going to make display and reset return a double. And that double is, whoops, and the double is basically going to be this. It's going to be the length of time that we're printing out. And that way we can do more with that than just display it. The second thing I'm going to do is a little bit trickier to understand, but what I'm going to be doing is I'm going to be taking in another parameter that I'm going to call the dividend, and it's going to default equal to 0. And what I'm going to be doing is, if dividend is equal to 0, then I'm going to perform the calculation as it is right now. But if it's not 0, then instead I'm going to divide by dividend rather than num invocations. And you might be wondering, why would I do that? Well, right now when we display it, we're displaying the average length of a function call. And that's useful in a lot of cases. But sometimes you don't want the average length of a function, of every single function call. For instance, wrong file. Right here. Let's say I wanted to profile the game's update function. This could be called any number of times during a frame. But ultimately, what we really care about is the total length of time that this function takes in a frame, regardless of how many times it might be called. So instead, we'd want to divide by, well, the number of frames rather than the number of times it was invocated. So that's why we're doing that. And here's how we're going to do that. What I'm going to do is I'm going to do 2 things. First off, I'm going to have a double. It's going to be called, well, first off I'll call this input dividend, sure. and then I'll have a double for the actual dividend. And the actual dividend is going to start off equal to input dividend. And if dividend happens to be equal to 0, or rather, if it's not equal to 0, then dividend instead equals the num invocations, which is exactly what we specified. There's one more thing we can actually do here just to make things more robust, and that's if dividend happens to be equal to 0 still, whoops, if it's equal to 0, then dividend, wait, I'm sorry, I'm getting ahead of myself. Also, I accidentally deleted the reset code for some reason, so make sure this stays in there. I don't know why I did that. But anyways, what we need to do is we need to make a double time, and that's basically going to be what this thing is right now, except we're going to store it in a variable. Why? Because at the end of the function, we want to return the time. So the way we're going to do this is, and that not equal to 0 should be equal to 0. If dividend is equal to 0, then we want to use the num invocations. Otherwise, we just want to use whatever they passed in. Anyways, now that we've cleared up all the ridiculous errors I've made for some reason, what we want to do, if dividend is equal to 0, then time should be equal to 0. That way we're not accidentally dividing by 0 or running into all the associated issues with that. Otherwise, then we're going to set time equal to what we had, well, in our print statement, except instead of dividing by num invocations, we're going to divide by time. And of course, in our print statement, we're going to be displaying time in place of the calculation. So with all that out of the way, we should be able to build and get a syntax error, and then build again. Time may be divided by dividend. Dang-nabbit. And then build again. And now things should work. Yeah. Good, so we haven't broken anything, thankfully. So, with all that out of the way, profile timer is a little bit more usable. And what I'm going to do is I'm going to change my display profile info function to return a double, and it's going to return this. And I'm also going to change it to take in a double dividend. Because right now we are calling render once per frame, surprise, but just in case, it's slightly more robust that way. So, wrong file. Yeah, so I'm going to pass in double frames here. And I'm also going to create a new variable. And I'm going to call this variable total recorded time, sure. And basically, this is going to start off equal to 0, and everywhere that I'm profiling, whoops, that should, yeah, make sure your braces are right. But anyways, everywhere I profile things, I want to set my total recorded time plus equal that. So this way, what I can do is that before my total time, I can print out other time. This is time that's still being used by the engine, but we're not profiling. And we're going to use, of course, total time minus total recorded time for that. So, again, time being consumed, but we're not explicitly measuring what's causing or taking up that time. And if we have a lot of time being used there, then of course, that's a pretty good indication that we should profile a little bit more of our engine. Also, one more thing that's kind of bothering me. Right now, for total time, we're assuming that frame counter is always exactly equal to 1, and that's rarely going to be the case. So I'm going to take this 1000, and I'm going to multiply it by frame counter, so that way it'll adjust properly for however many milliseconds have actually been taken up. And finally with that, we should now be able to run. And cool. So now, as you see, our renderer is taking up a little under 2 milliseconds right now, but we still have 15 milliseconds being consumed by the engine that we're not recording. So, to successfully profile your code, really, you just want to record as much as you can so that you have at least some idea of where big chunks of time are being consumed. So, really, we've done the hard part right now. The rest of the process is just putting profile timers where we need it and displaying it appropriately here. So I'll do one more example on screen, just to get the gist of it, and then I'll just show you what I've decided to profile for the rest of them. So I'm going to add one more thing to our rendering engine, and this is the last one. And this one is going to be, of course, I'm going to need the function, but I'm also going to need the profile timer. And this is not going to be render profile timer. This is going to be Windows Sync profile timer. Because you see, like I said, we're not recording this last part right here because this is when Windows Sync happens. So that's where we're going to this is where we're going to profile that. We're going to profile whatever time is used by Windows Sync. So I'm going to change this to Windows Sync thing, and then rename render time to Windows Sync time. And we're going to change this to display Windows Sync time, sure. Doesn't matter that much. In fact, I'll rename this to display render time. Not timer, but time. There. And rendering engine, wrong file. Core engine. Gonna, of course, rename the function appropriately. And in rendering engine.cpp, again, all I have to do to actually do this is take my m_Windows Sync profile timer, start the invocation before the code section I want to profile, and then stop the invocation after the code section I want to profile is finished. And it's that simple. So now if I go to Core Engine, I'm going to copy the line where I'm doing rendering engine display render time, and I'm going to change this to render engine display Windows Sync time. And with that, everything should be working now. So, well, you know, we should have yet another element in our whole profiling scheme. So if I build and run, you notice, hey, Windows Sync is taking a ridiculous amount of time. And now there's only a little over a millisecond, well, usually a little over a millisecond of time, that we're not quite accounting for in our whole profiling scheme. So, that's really the process. You add a profile timer where you need it, whether it be in a class, in a function, wherever it's appropriate. You add some way to access it from your central profiling thing, in this case it's the core engine. And then you just take your profile timer, start invocation before where you want to profile, and stop invocation afterwards. It's that simple. So I'm going to set up a few more places off screen because I think you get the idea now, and then I'll show you what I chose to do. Okay, so there were a few things I decided to go ahead and start measuring the time on. In-game, I did exactly what I said. I added profile timers. I added functions to access them because you normally can't access them. And other than that, I just did start invocation and stop invocation both before and after what I was interested in. In this case, it's the process input and update functions. And now in Core Engine, you can see, well, I'm displaying how much time is being spent on processing input and updating. Another thing I decided to measure was sleeping because, well, that's unpredictable. That can be 1 millisecond or 1,000 milliseconds. It just guarantees it's at least 1 millisecond. So I figured that's kind of important to profile. Window update timer? I mostly profiled the window update just because it's the only thing left in this whole loop that I wasn't profiling in some way or another, so I figured, you know, just why not? And finally, there is swap buffer. Yeah, I mean, that's still Windows thing down there, so the only thing left is swap buffers. Again, it's here because, mostly because it's left over. It's the only thing left in our core loop that we weren't profiling in some way or another. I also did a few very miscellaneous things, like I refactored profiling.h so we have a function to just get the timer reset without displaying if we don't want to display for some reason. You do not need that at all. I just figured it might be useful at some point. In fact, it probably will be useful at many points, but, you know. And also I added a way you can specify like how much white space should be added to the message so everything can be lined up nicely. And this is really, really basic. I just have string for white space. I'm concatenating on white space for the total difference between message length and display message length, and it's done. Very, very easy. And so yeah, let's just build and run. And now, you see, hey, look at that. We now are profiling just about everything there is. We know how much time is being spent on yeah, just about everything. So all our real time is being spent somewhere in one of these categories. As you see, effort time is a very, very marginal portion of our whole total time. So yeah, I'd say we're doing a pretty good job profiling the amount of time our engine is spending on various tasks. So yeah, hope you enjoyed, hope you learned, and I'll see you in the next video, where we'll implement more advanced profiling tools. Basically ways to say, okay, let's say the renderer is taking too long, that's 2 milliseconds, that's totally ridiculous. How dare you spend 2 milliseconds on rendering? So if that's you, how can you figure out, well, what's causing those 2 milliseconds? So that'll be sort of the topic of the next video. So thank you, hope you enjoyed, hope you learned, and I'll see you in the next video.